Hi guys, I'm Kiani. I'm from Iran and I want to discuss about the Google exam course. For example, the capstone project, as you can see it here. And this is my URL in this presentation. Let's talk about this URL. We have some new notebooks and this is my notebooks, as you can see it here. In the beginning of this presentation, we should talk about the some pip install datasets transformer evaluate. As you can see it here, the evaluate meanings is the some validation about the some project, and we should install some dataset as transformers and the evaluate and blah blah. We should upgrade the my pip. After that, we should install the disable pip version check and torch data, as you can see it here. And you know that about the torch and torch data. Torch is about just the one of the neural networks neural networks and the AI artificial intelligence. And Thor's data is about the artificial intelligence project, and we should now now about that. And we should install the transformers datasets, evaluate, ROG score, PEFT for the fine tuning and pre-training method. As you can see it here, some of the techniques and some of the method or methodology for the some project like this capstone project is really useful. And after that, as a matter of fact, or basically, we should know about the path, the rose score, transformers dataset, and evaluate. And we should install the github.com. You know that about the some technique and methodology for the some of the project like capstone project. And you in the course of the Google, we we receive some information about the reinforcement learning from human feedback method and techniques. It is about some techniques, and we should know about that. The dataset load dataset. The transformer auto model for sec to secular LM. For the large language model, we should import this module. Auto tokenization, generation config, training arguments for the augmentation and training. Some technique of the training is the two type. We have a two type of techniques in the training: fine tuning and pre-training is about the large language model training. And we have a training, we have a torch, we have a time, we have evaluate, we have a pandas as the data frame. We should know about the pandas as it's about the just data frames. And we should know about the numpy as a mathematical project. We should use it. um, we should have a transformers as pipeline. We should have a transformers dataset and PIFT and blah blah. Okay, as a matter of fact, we should have a TRL. TRL is a transformer reinforcement learning library, and that one we use the when we use the TRL is about the reinforcement learning from human feedback and prompt engineering. You should know it. You should know it as well. And we have a Hugging Face data set name, set feed BBC News for the summarize the BBC News segmentation, and for the summarizing the new sentences, we should have it. We should have the Hugging Face dataset name. After that, we should have some variable as load dataset Hugging Face name dataset as an input, and we have an example index as the 40 and 200 dash line, and for I index in enumerate example index, we should have a I index and enumerate, and we have a print, lot of print. That's about, that's about the dataset index and dataset indexes. I'm probably wrong. And we have a model name. As you can see it here, to be creative in the project, we use another model from Google itself. And for example, we have a model name. After that, we should have some of the another model, like Gemini, and we should use the Flan T5 base as a creative in the project. As you can see it here, we have a model and auto model for sequential LM for pre-trained, and we have a pre-trained technique or method or function, and we have a model name in the input. In the another cells, we have a tokenizer, auto tokenizer from pre-trained model name use fast as you can see it here. And we have some description as a descriptive cells. We have a tokenizer installation. We have a tokenizer in initialization. Tokenizer, as you can see it here, we have some descriptive about the tokenization. Tokenizer initialization. This line initialize a tokenizer token using the auto tokenizer class from the Hugging Face Transformers library. The from pre-trained methods load a pre-trained tokenizer based on the specific model name. They use fast true argument and indicates that a faster version of the tokenizer should be used if available. Sentences definition. The sentence, some of the sentence we have to definish is about the Lopez Mysteries UK scarcity in the index 00. Okay, and this lines defines a string variable sentence, and we have some of the variable as a sentence that contains a news article or report about the Jennifer Lopez missing a charity primer due to illness. Encoding the sentences. Okay, we have autoencoders and encoding and decoding in this exam. Sentence encoded tokenizer sentence return a tensor's PT, and this line encodes the sentence into a format suitable model to return an argument specific that the output should be in the PyTorch or tensor format. And we have a decoding layer, the encoded sentences. Sentences, decoded tokenizer, decode sentences encoded input ID, and a lot of descriptive in the here. And in another says we have some the for loops structure in the for I and index in the enumerate example index. We should have a dialog, and dialog as a what? Dialog as a news. Okay. After that, we have a prompt and dialog for the prompt engineering of the dialog. After that, we have some of input and some of output. In the input variable, we have a tokenizer, prompt, return tensors, pt, and output tokenizers is decode the model generate. Okay. After that, or basically, we have a print dash line for the discipline of the code and print example I plus 1 and blah blah. In the literature of the this cells, or in the descriptive of this cells, we have a iterating over example index. For I index in enumerate example index, this line starts a loop that iterates over a list of example index. Example index, the enumerate function provides both the index of the current iteration and the actual index from the list. Retrieving dialog from the dataset and constructing a prompt. We have a prompt engineering in this section. After that, we have encoding the prompt in this section and generating output from the model, and finally we have the printing the results. We have a summary. Overall, this code snips how to use the model and analyze the dialogue by asking the interpreted contents or even the described in the dialogues, and it constructs a prompt, encodes it, generates a response and prints the result in a struct format. And approach is an example of the zero shot learning. Okay, we have some of techniques in the Google course, and we have a zero shot learning. The zero shot learning is a most popular learning in the machine learning, deep learning, and generative AI, where the model is asked to perform the task interpretation without having been trained on the specific text. And we have some of the cells, like the we have some of the cells in the last for to be continuing. I want to say that about the PD and last cells. PD sets option display max claw width white, or I'm sorry, I mean wrong. The 500 and df compare the results, PD data frame compare results. As a data frame, we have a PD for the methods, and df compare the results reward diff, and df compare the result reward diff, df compare the result reward before. This sales meaning is about they store and review the results in the data frame. Finally, we have the end of this meeting and this presentation. Sorry about some pronunciation, some fast pronunciation, and my pronunciation is about my accent, and my accent is not true. It's the false. It's the false, really. I'm sorry about that, really, and I'm sorry I went wrong in some of the pronunciation and some of uh, some of my pronunciation, and in some of my results and summary and reading and blah blah. Great to see you here, everyone and everybody. Thank you, and thank you very much. Goodbye.